that in a second. All right, so correlation, linear regression. What are we talking about? What is correlation? Quickly. What is it? A bunch of tools to measure what? Two variables, and what are we measuring between the two variables? The relationship, but what about the relationship? What characteristics of the relationship? Huh? The direction. Y'all gotta help me out today. Your buddy's not here. Direction and what? Strength, remember? Are we awake today? Is everybody falling asleep? You know it's gonna be dark by the time we finish this class. Then you can go to sleep. Don't go to sleep yet. Alright. So, correlation. We're measuring the relationship between two variables, and we're measuring with correlation, we're measuring the direction and the strength. Remember this? So we have independent and dependent variables. Independent variables are, where are my markers? Okay. We have independent and dependent variables. The first technique that we use to explain the relationship between these variables is what? We graph them out somehow, don't we? What do we build? What? Help me out here. What do we build?
Scatter diagram.
Very good. A scatter plot here, don't we? And we find that best fitting line through there, don't we? Okay. What's the problem with that, though? Well, first off, before we do that, where does the independent variable go and where does the dependent variable go?
Independent X, dependent Y.
Very good. Independent X, dependent Y. Did y'all hear about my new analogy or my new mnemonic device to help remember which is X and which is Y?
I don't think so.
Okay, so I'm generation X, right? And I'm completely independent.
Oh yeah, you did.
Did I tell you that about
I
that?
don't think so.
And you all are generation Y, and you're completely dependent on everybody for everything? Yeah, so Y dependent, X independent? Just kidding. Just teasing. Is nobody upset about that? Okay, I guess I'll have to push a little harder today then, huh? Y'all look like you're about to fall asleep on me. This is ridiculous. Does everybody need to come up to the front? Do we need push-ups? I'm not just going to stand up here and blabber. I need help. All right, so X and Y. Then we find that best fitting line through there. What's the problem with that line, though? What's a little subjective, isn't it? What do you see right there? Do you see a strong or weak directional relationship? What do you think?
Strong.
Strong, what do you see?
Strong.
What do you see?
Yeah, it's strong.
Nobody sees weak?
I can't tell.
You can't really tell, can you? It's kind of subjective, isn't it? But what's not subjective? If we came up with a number, right, using a formula to represent that strength in that direction. And we have that, don't we? It's called the, very good, correlation coefficient. Remember this? Falls between what?
Negative
1 and 1. Very good. -1 to 1. So it's really strong down this way, and down this way it's really weak, right? Remember? Is that true?
No.
No.
What is
It's
it?
strong negative.
It's strong negative relationship this way, isn't it? Strong positive relationship this way. Over in here, it's weak in the middle, and at 0, there's no relationship. Remember these? No relationship there, negative there, and positive there. Remember doing all this? All right. So there's the formula for it, but we have Excel, don't we? Everybody open your Georgia View. This will get you going. Everybody open your Georgia View and open that file, Applewood file. Okay? Everybody have it? Who does not have it? If you are here, please raise your hand. Almost everybody's here. Good job. If you're not here, please raise your hand. Well, at least nobody raised their hand, so that's good. All right. So, I'm handing out prizes today. And you're going to like this prize, I promise you. And you're going to win the prize if, does everybody have it open? You're the first person to build a scatter plot with a trend line. Go. You're going to like this prize too, I promise you. Scatter plot with a trend line. Using age and profit. What's up?
Done.
You're done?
Yeah.
I think Volzer beat you though.
Okay.
You got my attention first.
That's all right.
All right, so now you get 2 prizes. Your first prize is you get to tell me how to do it. How'd you do it?
Select the columns and do a search chart.
Very good. We select the columns. We go to insert. I'm gonna go back up at the top here because we're gonna build on it. I'm gonna go to insert and what? Charts. And I'm gonna insert a scatter chart right there, huh? How does Excel know which is my X and which is my Y? It did it correctly. Didn't it? Put my age, my independent variable across the bottom.
By which one's first?
By which one's first? Remember that? So make sure you have your independent variable in the left-hand column, left of the dependent variable. Now, how do I get the trend line in there?
Plus, check the
Hit the plus sign and do what? Check trend line, right? Let me make that bigger. Does everybody see that trend line right there? All right. Very good. When I ask you to build find me the correlation coefficient 2 different ways. Ready, go. You're like, more work. Great, that's a great prize, huh? Porter has it. All right, let's check it out before I award that prize. All right, how do we do it? 2 ways. What's the first way?
Equal
Equals
C-O-R-R.
C. Very good. C-O-R-R-E-L. I'm in tab there, and then what do I do?
You array or select a column, everything in the first
Select the A column, then what?
column,
Comma.
select everything in B,
Select the B column, and then what?
close and enter.
Close it and hit enter, and what do we get here? A correlation of 0.261, and that is correct, remember, because we looked at it already once, didn't we? Did we do this already? Okay. Now what's the second way?
You have to insert the data pack, so
Okay.
file.
Well, first I'll check to see if I have it. Do I have it? No, so I do have to insert it. And how do I do it? File,
File, options.
options,
And you go to add-ins.
add-ins,
And then go. right
Go.
there. Analysis toolpack.
analysis toolpack.
And then it'll give it to you.
Where? In data, right? I'm under data, and I go to data analysis. And what do I do?
And then you click correlation.
Correlation,
Okay, and then highlight A and B,
whole thing, right?
everything in it, and then in labels in the first row.
Very good. I put my labels in, so I got to click labels in the first row. It's in columns. I'm gonna put my output range somewhere, right?
Yep, output, and then pick a square,
Pick a spot to do it. Pick a spot to do it. I'll do J3,
and then okay.
and then OK, and I got it, don't I? Very good. You get a prize. A pack of polymer gloves. So, we good with Excel, right? Please remember, like I said, I'm not going to be here, so you got to remember how to turn this data analysis package on, don't you? You're not going to be asking, you're not going to be talking to people once the test starts. You can ask the person. You're not going to be going on to Google either on your phone. All right? So that's just something you got to remember. Okay. We're about to come back to that, so I'm just going to minimize it. Now, testing the significance, remember doing this? Now, the only hard thing about it was what? Same 6 steps we've been using. The only hard thing about it is a couple things different. We set our null hypothesis to what? 0, don't we? So we're going to say, if we prove that it's not 0, i.e. we reject that null hypothesis, it's saying that, hey, there is no significance to that correlation. See what I'm saying? If we do not reject the null hypothesis, we're saying, yes, there is 0. There is no correlation. Right? Everybody understand what I'm saying? But if we reject it, we say there is correlation, don't we? There's not none. Okay? All right, so what's the other tricky thing we have to remember about this with our critical value here? Right here. What's the other thing we have to remember about our critical value? Remember, we go to the right or the left of the critical value, don't we? What's the other thing we have to remember here? Who remembers? Well, we use that t-table, don't we, to find that critical value? And we use it the same way. So this would be two-tailed, in fact, I have it pulled up. This would be two-tailed. This is 2.16 is what they found for this critical value, isn't it? Okay, so it's 2.16 we said? Let me get down here to the table. Now,
Oh,
student Steve, huh?
the degrees of freedom, you gotta subtract 2.
Very good. You got to subtract 2 from the degrees of freedom. And why is that? How many variables?
2.
We got 2 variables, don't we? So remember, this example is 0.05 at a two-tailed test, and we had 15 points in our a sample size of 15. So it's not n minus 1 here, it's n minus 2. 13 gives us that 2.16, doesn't it? Remember that? Okay, so that's the only little wrinkles in there. Got me? Open another instance, I meant to do that. Okay, this one, remember, we reject it because it falls outside. It falls way outside, as a matter of fact, 6.216. Oh yeah, and our t-test is different too, isn't it? But you're going to have a formula sheet for that. And it's not complex, it's just knowing to plug stuff in. But you do need your R in there, don't you? So this is the t-test for a correlation coefficient. Now, regression analysis, guys. Change of subject. So we started in on this, didn't we? So regression analysis. So we did our correlation stuff. Now we're going to use that in regression. What are we talking about with regression? So we're still talking about 2 variables, but we're talking about defining not just the strength and the direction of the relationship, but the actual relationship itself, essentially, aren't we? What we're really saying is, for however many x's we have, it's going to be so-and-so number of y's, isn't it? Okay, so here's what I'm saying, for those of you who don't remember. We got our x and our y chart here, don't we? And we got our data set here. Blah, 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 whatever it is. Okay. And using the least squares principle, who remembers what that was? So do you remember, we want to get a line in here that minimizes the distance, remember this? Between each variable in the line, aggregated sum, don't we? Remember? Remember this example? We have one like this, and our data looks like that. We have a line straight through it, don't we? Straight through those variables. Do you remember this?
There's no space.
Yeah, there's no space between each variable in the line, is there? Therefore, that is the best fitting line. This is minimum as you can get, isn't it? 0 plus 0 plus 0 plus 0, because there's 0 space for each one of those. That's as small as you can get. Let's say one of these is just, instead of there, it's 1 off. What would our sum of least squares be right here? It'd be 1, wouldn't it? 0 squared, 0 squared, 0 squared, 1 squared. Yeah? Okay. But the point is, we're not going to have a line down here, are we? Because that introduces tons of space, doesn't it? It doesn't make sense to put a line down there. So we want to minimize the space, the vertical space, between each variable and that line that we determine is the best fit. Okay? And again, we'll look at the formula for the line in just a minute. We've looked at it once, we'll look at it again in just a minute. Alright, so, what are we doing here? So, what we're essentially saying here is this. We got 15 variables here, let's say. Yeah, or all our copier salespeople. You tracking? You know what I'm saying here? Alright. So we don't even need to take a 16th out for that sample in order to be able to predict where we think a 16th salesperson might fall with however many calls. Let's say, for instance, the 16th salesperson, we're just going to make a prediction, right? That's the true beauty of this, is a prediction tool, okay? But we have that sample of 15 out of the 3,000, 3,500, whatever salespeople, right? Remember that? And say, and we're going to ask ourselves, so if we were to add a 16th person to this sample, approximately how many copiers could they sell if we had to make 50 calls, let's say? So let's say 50 is right here, yeah, for our X. How many copiers would we expect them to sell? Well, we have a prediction line for this now, don't we? Because we've averaged all these together and found the least squares, the one that comes closest to as many of these variables as possible, where we drop that aggregate number to the lowest so we have the best fitting line, and we're going to say boom, 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 boom. Well, this is where that x would fall on the line. So where's the corresponding estimated y for that x? And this would be the number of copiers we expect them to sell, wouldn't it? Now, it might be off a little bit somewhere, but it's the best estimate we have, isn't it? Does everybody understand what I'm saying? It's got to fall on that line because we got this line from the data set itself, didn't we? Okay, so that data set's the best we have. That sample's the best we have. All right. So, regression analysis, an equation that expresses the linear relationship between the two variables, isn't it? Okay, least squares principle, that's what we're talking about. We want to minimize the space between the aggregated space, right, between the variables and the line itself. For instance, right here. There's a space of 2, 4, 2. It wouldn't make sense to draw a line down here where the space is 3, 12, and 11, would it? Doesn't make sense. That adds up to a lot more than 2, 4, and 2, doesn't it? See what I'm saying? Okay. Yeah? All right. So here's that formula. I think this is where we left off last time. The general form, general form of linear regression equation. Okay. I've never called it that before. Didn't even notice that these notes said that. But anyway, here's your line equation, okay? Your regression equation. Y hat, what is Y hat again? Well, it says it right below, but what's the key word in there that makes us put that hat on there?
Estimated.
Very good. It's the estimated value, isn't it? Everybody see that? Y hat is the estimated value of y for selected value of x. So A is the what? The constant or the intercept. What is the intercept? Who remembers? That's the intercept, isn't it? See that? Where it hits the y right there? That's your intercept, isn't it? So that's really your starting point for your graph, huh? For your line. B is the slope of the fitted line. What are we talking about with slope? Yeah, that's it, isn't it? So all we're talking about is this. Boom, boom, huh? And we're going to come up with a number right here, aren't we? That's going to be your B, essentially. And that's going to be a 1, isn't it? Okay, and then x is what? Well, we're going to define an x, aren't we? Because x is what we're manipulating. Here it's the 50. We're going to slide it back and forth to see where this y hat will fall, aren't we? I mean, I should make some kind of little tool where you can just pull it back and forth and it shows you how to give it with the line. I'm sure there's something online. But I was thinking like an actual thing, you know what I mean? Anyway, everybody understand what I'm saying here? Yeah? So who can look at these formulas? We've already looked at the formulas. Who can look at these formulas and tell me why we would do B, the slope first? Why would we solve for B first? This one. Huh?
Because you have to know B to get the intercept.
Very good, because you got to know B to plug it into A, don't you? And to plug it into there, don't you? So you can't solve without that, but you can't solve that without that, huh? So that one, and then that one. That's our order, okay? Slope, intercept, and then plug it all in. We good? All right. Now, let's do an example. Recall that North American copier sales, remember what we're talking about here? Our 15 salespeople. The sales manager gathered information on the number of sales calls made and the number of copiers sold, using the sum of least squares to determine a linear relation to express the relationship between the two variables. All right, so the first step is to find the B, isn't it? What we just said. Because we got to use that B in the other ones. So what are we going to do? Remember our R that we already saw for before was 0.865. Remember, it was a strong relationship, wasn't it? Remember that? Strong positive relationship. times our 2 deviations gives us that. Now, we're not going to go through all the math here because we're going to do this on the computer, frankly. But anyway, 0.2608. So where would I plug that in on this graph over here? That's my B, isn't it? 0.2608. This marker's done, I think. Yeah. I'll have another red one. .2608, right? Next, find A. Where's my A on here? This is the A right here, isn't it? What is it? 19.9 what? 6. Yeah, 1996. Great year. Great vintage. All right. So now, what do I have? I got my formula, don't I? Y hat equals that plus times what? Well, whatever we plug in there. So what are we going to plug in there? Well, here's a problem right here. So if a salesperson makes 100 calls, he or she can expect to sell how many copiers? Well, our X that we're going to manipulate this thing with is right here, isn't it? Over here, 100, yeah? So we're going to plug 100 into here, and we're going to solve for our Y hat. Just do the math out, and we get the estimated Y is going to equal 46.04. So if my 100's right here, let's say, bring this line up. It hits right here, doesn't it? And my Y hat right here is 46.04. Everybody see that? Pretty cool, huh? I can tell you're all thrilled and amazed and impressed. I love being on the other end of that. All right. Blah, blah, there's that again. Now, regression equation slope test. Same thing that we did, right? Set our hypothesis to, hey, there is no slope on here, or there is no slope. Okay? Or at least inequality in that. But here, there's that one. But y'all have these slides, look through it. Please notice, we do use n-2 for our critical value, like Peyton said. And we also have what here? A different t-test, don't we? This one tests the slope. So please note that we're using different test statistics, aren't we? Which has always been the case, hasn't it? Sometimes we use z, sometimes we use t in the past. But we use the appropriate test statistic for what we're doing. That's what it all boils down to, huh? Okay, so evaluating a regression equation's ability to predict, okay? This is the last really big idea we have for this chapter, okay? Now, at least is what we're going to talk about today. Now, let me show you something here. Let me show you something. All right. Let's pretend like we have two different distributions. All right, one looks like this. Okay, one looks like this right here. Okay, and one looks like this right here. All right, but when I do my math out and I find the best fitting line through all that stuff, yeah, using my equation, my regression equation, I find out that the line, the best fitting line, looks like this. Oops, dang it. That was a good looking graph too, damn it. Jeez. What time is it?
5:23.
5:23 out of what?
6.
Oh, we got like 40 minutes. No. Put it down here a little bit. Does that look better? What do y'all think? Should I put one? I'm gonna take that one and put it in just a little bit. What do y'all think? Does it look good? Okay. Just wanted to look good for y'all. I get all kinds of complaints about my writing, so I want to make sure it looks good down. All right. But instead, I'm gonna put it down here. Boom, like that. And this one, I want to change that. What time is it?
6 o'clock.
Oh, I better hurry. All right, so it looks like that, doesn't it? All right, now, these are both 15 dots, yeah? Now I'm going to put a line like that through there, okay? That's my best fitting line. Now this one, I'm going to put a line through here, like this, boom. And let's pretend like these are the same line. In other words, it has the same slope. It has the same y-intercept. Okay, does everybody understand what I'm saying here? These lines are precisely parallel. And not only that, they fall right in the same spot on the graph, okay? But can you tell me, what's the difference in those two distributions? They both have the same number of variables. There's only one difference on those two graphs, and what is it?
That one's strong and that one's weak.
Well, it's not necessarily an issue of stronger or weak per se, but yes, visibly, what is the difference?
And those are closer together.
Because, I mean, they're both the same, they both have the same correlation, okay? But what now? What'd you say?
I was just saying the dots are closer together.
Yes, exactly. The dots are closer together. We can call that the what? An idea we've looked at lots this semester. The dispersion, the spread, couldn't we? So remember this here? Oops. Man, I already forgot how to draw a normal curve, didn't I? We got two of these, yeah? So they could have the same mean, but way different standard deviations, couldn't they? And why would they have that? Because it's how the data clusters around the mean, wouldn't it be? Okay, we can almost look at it like this, just turn it sideways, same thing. We got different spread around, essentially it is a mean, isn't it? See what I'm saying? Okay, but at the same time, that line is the same for both of them. How could that be so? Because for every low one over here, it's balanced out by a high one over here, isn't it? You see what I mean? So the best fitting line is still going to be in that same spot, even though these are just a lot tighter than these. See what I mean? It averages to the same, doesn't it? Okay? All that is to say this. But this would give it, we would have to have a way to measure that spread though, wouldn't we? In order to tell us how strong, how accurate the prediction is going to be when we pick a certain x out of that y, okay? Meaning this. We're going to call it the standard error of the estimate, and what it's going to tell us is this. Let's play a hypothetical here. Let's say that right here I picked 50 calls again, and I brought it up here, and my p-hat was wherever that is, yeah? I'm not my p-hat, my y-hat, okay? And here I have 50 calls, and I bring it up here to the same place, and I bring it over here, and my y-hat, again, is wherever that is. And again, it'll match, won't it? Because that line is the same. But let me ask you something. Which of these predictions, i.e. the point on that line, do you think is more accurate? Which of those two is more accurate, would you think?
Top.
The top one, and why is that?
Because we're more clustered.
Because they're more clustered together. So you know, given what you have already, your sample, you know that from here, it might not be exact, but it's only going to fall from here to here, most likely, isn't it? The whole range of what you've had is only here to here. Therefore, here's pretty accurate. It's really close to your extremes, isn't it? To where it's likely to fall. Here, where are your extremes? All the way up here and all the way down here, aren't they? So you got a lot more range for the sucker to fall in and still be consistent with this line. You see what I mean? Is everybody following me? Yeah? It's kind of intuitive, isn't it, when you look at it? That's why we graph this stuff out. Okay? What I'm saying is, to be considered reasonable, a reasonable estimate, it could fall all the way up here, or it could fall all the way down here. You're still within the range of your other variables, aren't you? But that's still a lot of space, isn't it? Here, the reasonable range that this estimate could fall into would be here, wouldn't it? Like here and here. That's not nearly as much space, is it? Therefore, it's probably a better estimator of this one than this one, isn't it? Okay, now we're going to look at this spread right here and say, hey, that's going to tell us how good of an estimator our line is for the data set, for the population actually, okay? All right, so it's called the standard error of the estimate. Who knows what the standard error is? If somebody does not tell me the standard error, I swear.
Standard deviation.
Of
That's in this case.
what? It is of the sample, but what is it that we've looked at so far? Of the sampling distribution, right? The standard deviation of the sampling distribution. Remember doing that? And what does it look like? How do we write that sucker? It's just standard deviation of the population, right sized by what?
Square root of the sample size.
Square root of the sample size. Yeah, very good. Y'all remember that? Just like the running shoe. Remember? On, right? On running? Didn't we look at that? The running shoe? Did I tell you about that? Yeah, I'm in the gym at the Y. And I look up and on top of the locker there's two shoes. And I'm looking at the back of the shoes and this is the back of the shoe, okay? And they look like this. One has this and one has this. And I'm like, are you kidding me? I said, stack those on top of each other and you got the standard error. Fascinating, huh? I almost got my pen and drew a thing on there like this. But then I looked them up and they were like $130 shoes. I was like, maybe I shouldn't do that. All right, so standard error of the estimate. Variation around the regression line. That's all we're talking about, isn't it? Okay, how big is that spread around that line? Okay, based on the dependent variable, i.e. the distance up and down, not the distance left and right. Based on the square deviations from the regression line. Why do we square? Why do we square them? Get rid of the negatives, blah, blah, blah. Small values indicate that the points cluster closely around the regression line, doesn't it? Makes sense, doesn't it? The bigger the value, the more space, huh? And it's computed using this formula. Now, this formula right here ought to look familiar to some folks. Anybody ever seen something that looks like this? In fact, let's go to the next slide here. There's the formula right here. Who can tell me what this formula is when I say it? I'm going to say it right now, okay? The square root of sigma times x minus x bar squared over n minus 1. Does that formula ring a bell to anybody? And then you build it out on a chart that looks like this. X minus x bar, x minus x bar squared, and then you add it all up. Standard deviation, very good. You win a prize. You get to do a point supplement. Or you can have the gloves. You want to pair your gloves? All right. Everybody remember standard deviation, right? And what did standard deviation tell us? It was just a measure of what? Spread of variance, wasn't it? It was a square root of variance, wasn't it? Of the spread from the mean. That's all we're talking about here, isn't it? But we're going with y's, aren't we? Up and down instead. And we're using our estimated y to the line, not the, or to the average, not the, or to the, yeah, to the estimated line from the point, okay? Not the x minus the average, the x bar. Got me? Okay, so exact same formula. You can chart it out the same way. But we're not going to chart it out, are we? What are we going to use? We're going to use Excel. Aren't we? Yes, we are. One more thing I want to look at before, this is the last slide we're going to do today. We'll start with this. as a refresher. Coefficient of determination, what are we talking about here? So this is the formula for it, but what are we solving for? Right there. Coefficient of determination. What does it say we're solving for?
Portion of the total variation in variable y that
Is what?
is explained,
Or what?
accounted for,
By what?
the variation in the variable.
Which is what?
Okay.
In the sentence.
Oh.
Period. Just kidding. Yes, that's what it is. But what is that letter right there when we solve for it? What are we solving for?
R squared.
So you got that formula, or you can just square your r. Got me? What are we going to do? We're going to square the r, and we're going to do it in Excel. All right? Same thing. So the proportion of total variation in the dependent variable. So how much does your y vary given your variation in x? Okay, and it's a function of the spread, isn't it? Okay. All right. So, are we ready to go with Excel? Everybody open Excel. We're almost done, people. You're going to owe me a bunch of minutes after today. So, does everybody remember how to make a copy of a worksheet? How do we do that? Somebody explain it to me.
Right click
Where?
on the,
Tab down here?
yeah,
Very good.
move or copy.
You must have had a really good teacher for Excel.
I did,
Yeah. So we click on move or copy, don't we? Yeah. And we go to what? Let's move it to the end here. And we're making a copy, aren't we? So what do?
Create a copy.
Click create a copy. Very good. And we're going to click OK. And what do we have here? We have the exact same sheet, don't we? Everybody get that? You need to make a copy though. I don't want you changing the first one. I want y'all to save this today if you want to, so that you can have this to refer back to. Because again, who's not going to be here? Me. Guess what? When you email me and I'm down in South America living the good life, you think I want to deal with you? No. I want to be surfing. I'm going to be getting massages. It's going to be awesome. And I don't want to be interrupted. Does everybody understand? Just kidding. I will be in classes though from like, what, 8 a.m. to 6 p.m. every day. So, and I get like a lunch. All right, so if you don't hear back from me quickly, that's what it is. All right, so. So let's use one of those sheets. I'm going to use the copy. Okay? You leaving?
No,
Okay. I just like packing up. I was like,
no, we're just doing Excel now.
okay. All right, so let's delete all the stuff we did for the correlation, okay? So I'm just going to highlight everything from F to L and go delete. Did you get a copy? Did you get a copy? You don't know what I'm talking about. Did you get it?
No, I had, well, that minute took so long, so I put it back down. So
Wait.
I'm making that-
No, go ahead
Pull it
and
back
let's
up.
do it. Yeah, let's do it. Let's run through it. Let's wait a second, guys.
How come mine won't delete?
Hmm?
Like, press and delete. and you do-
Right click and delete it. See if it makes a difference. Shift shells left. Yeah, that's fine. There you go. Sometimes it does, sometimes it doesn't. I don't know. Did everybody get the new sheet ready to go? Okay. You good? You gonna open it up?
Yeah.
Okay, let's wait just a second, guys. We got plenty of time. It's just less time you'll owe me. Don't worry. But I want everybody to run through this. I want you guys doing this by hand, okay? This one's really easy, though. Okay? You good? What are you doing? Oh, your password? Oh, are we doing this again? Oh, my God.
Told you. I had it pulled up and I thought I was done with it.
What? You should be on Georgia View all the time, though. Oh, but it saves in your computer at home, doesn't it? In your work computer. Here it doesn't save. Tell me when you'll have it up. Are you looking for your password?
No, it's just loading.
Okay. What do y'all want to talk about? Feelings? Relationships? Recipes? It's dark outside. Who would have thought that would happen? You got it?
Says it might take several minutes.
Are you serious? Did you do the other one?
Yeah, I did the other one.
And you closed it down. You thought we were getting out of here.
Because you said it was the last slide.
Ah, tricked ya. You on? Are you on or is it signing on?
No, no.
Okay, so you see your announcement right there with Applewood Auto
Oh,
Group?
I then went on to the thing.
You're on Excel?
Yeah.
You're here?
Yeah.
Okay. So we just we're waiting on one. Is it coming?
No, it says it's going to take several minutes.
Here, let me make it go. It's not. Ready? Go. There you go. I got the magic touch, don't I? All right. And you know your password and all that stuff?
Yeah,
Okay, now, well, let's get you a new spreadsheet here.
I did.
You know how to do it?
I did, right?
Yeah, you did it right. You did it right.
I did.
She did it right, everybody.
No, I really.
How did you know how to do that?
I just seen them.
Really? Good job. Really good job. Do you know how to do it?
Yes.
Okay. Wow, some days, you know, it's a rough job, but some days you go home and you're like, today was worth it, man. I changed somebody's life today. I'm just kidding. Oh, Lord. You got it?
Yeah, go ahead.
Okay, let's go. You ready? So what we're going to do is what? We're going to go in here and we're going to download the data analysis package again, aren't we? No. Why are we not going to do it again? Because we already did it. So where is it?
Data tab.
Under data. You might have to do it again. Can you remember how to do it? Deborah, can you remember how to do it?
I got notes.
No, Peyton's going to walk you through it. How do you do it? Just listen to Peyton.
Okay.
Ready?
File.
File, options,
Options, yep.
add-ins,
And, yep.
and then click go at the bottom.
Add-ins.
Just hit go.
You see go down there at the very bottom?
I got you. Yep.
And then click analysis tool pack.
Okay.
And then okay.
And that's it. Now go to data across the top.
Okay.
You see it over there on the far right?
Nope.
On the far right.
Yeah, it's over there.
Where?
I think.
Oh, right there.
Yeah.
Yep.
You got it? All right. Look at that.
Thank you, Peyton.
You will.
We got some Excel pros in here. All right. So, what are we doing here? We're not doing correlation anymore. What are we doing? Regression, aren't we? So does everybody see where it says regression right there? Let's double click on that. Everybody with me? And what do we have? What's it asking us for? The Y range and the X range. So Y is first. Which one is Y? This is Applewood Group, so we're talking about age and profit, right? So profit is the Y range, isn't it? So we want to go Control Shift down, don't we? Oops. I'm in the wrong place here. I thought I was over here. So we want to click on V and Control Shift down, don't we? And now we want to click in the X box.
Oh, mine's upside down.
Do we include the title or no?
Did you just say yours is upside down? Yeah, you can include the title. But if you include the title, what do you have to click? So let's watch for now. You're close though.
I got you.
You're getting there, little by little. All right. So now we are going to include the labels. I highlighted the labels. You don't have to, but I highlighted them. So I'm going to click labels. Otherwise, it'll say there's non-numeric data in there, okay? Now, output range. I'm just going to output it. That's just saying where you want to put it. I want to put it up here in H2, okay? We good? Now, okay, everybody, well, I think we're all caught up. Now click residuals. Does everybody see that? We want to add the residuals in there. We good? And then that should be it. Click OK. We could click the confidence level. We'll look at that next time. And click OK. Ready? What do we get? a summary output, didn't we? I'm gonna bring it over here. So what are we looking at here? Okay, so remember in our data set, or in our, what am I trying to say here? What am I trying to say here? Our descriptive statistics. Remember when we did that? So this is kind of that for a regression, isn't it? It's the descriptive statistics of a regression, isn't it? Okay, so what are we looking at? What's this multiple R? Okay, that's just our R value. That's just our correlation, isn't it? Remember when we calculated it? It was at 0.261? That's all that is. That's our R value. So instead of doing equals coral or doing correlation in the data analysis package, now we have another way to do it, don't we? Okay? R squared, what was that we just looked at? The coefficient of what?
Determination.
Determination. Very good. So that is squaring our R, isn't it? That's all it is. Okay? Explaining that movement. Why does that happen when we move that X a certain way? Okay? Adjusted R squared we don't need. Standard error, what is that? Remember looking at that? Huh? Well, yes, it's standard error, isn't it? But remember looking at that? What was that? It was the... Huh? No, not that one. It was this one, remember? It was this. How much is that spread? How wide is that spread? Remember? This is that was the of a normal of a sampling distribution, remember? All right. Now let's go down. We didn't do ANOVA analysis. We skipped that chapter, but that's analysis. That's analysis of variance testing. What am I trying to say here? ANOVA testing of variance analysis. It's variance analysis, okay? That's what that is. Okay, now, what's down here in our coefficients? What are these? What do you think that intercept is right there? What's the intercept? So this represents that line, right?
A.
Very good. That's the A in our line, isn't it? This is where that line crosses that. This is where the line crosses the y-intercept, isn't it? Everybody see that? That's that right there. In this case, it's 11:10, isn't it? 11:11, really. Yeah, this one's done. It's 11:11. Okay. Very good. And what is this age right here? So for every one we go over, what do we do? Wait a second. For every 15, what happens for every car? For every, wait, what now? Oh, age is 15.96, right? That's our slope, isn't it? Everybody see that? Okay. So there's t-stats, p-values, our 95% percentiles. We've looked at all this, haven't we? This is all stuff we've looked at before. Okay, so again, you could look at this as our descriptive statistics of the regression line, okay? Of the regression analysis. So this is a lot easier doing it this way than doing all those big formulas, isn't it? Yeah? Okay, we'll look a little bit deeper into this on Tuesday because we're going to do the example with the salespeople, all right? And then we'll have it printed because we've done a lot of that on the slides, and we'll have it to compare to. All right, so I need you to open up your Excel in the first person to build me a scatter plot, and 2 ways of doing correlation gets a point. All right, how do we do it, Justin? Everybody watching this? If you don't remember, please, this is the last day I'm going to be able to show you how to do this. The person, I already confirmed it, the person that is going to be proctoring your exam does not know how to do this. I already confirmed it today, okay? So I said, good. I had somebody else lined up, but since you don't know how to do it, I want you to do it. She said, can they ask other people? I said, nope. I said, you better know it. I'm serious. How many times have I told y'all that?
Yes.
Told you that a bunch of times. You got to know how to do this. All right, so how do we do it, Boulder? Select the data, all of it, right? And then what?
Insert,
Insert, and then what?
chart.
Charts, and to there, right?
Yeah.
Scatter plot. Now I need that trend line in there, don't I? Right there? And then what do I do?
Check box, try.
Check box next to trend line, and what do we get? Nice, we got a chart with a trend line. Now, you may be asking, why am I building this? We haven't done anything yet with it yet, but we're about to today, okay? So that's why we want it on there. All right, second thing. Oh, what's the second thing I asked you? Correlation, right? How we do that?
Equals core.
I'm asking Volzer, you didn't get it.
Either use the data tab or do equals.
Well, you're gonna do it both ways. What's the first way? Equals.
Equals
What? Huh?
or COREL.
There we go. Equals coral, right? And this is the quickest way probably, isn't it? We pick an array.
0.8. I want to see if can I get a point? If I got that right, it's already up here. Where's it?
You didn't get it right though.
Maybe it's right here.
Oh, you're talking about,
I did that one first.
you want a point for figuring that
Yeah,
out?
got it.
Even though we've been doing this?
I got it right too, see, look.
But I
Good for
remember.
you.
Mine was on there like 5 minutes ago.
Now, there's going to be another chance to get a point here in just a second. Okay? Volzer's got this point if he can land it home. What's the last way?
Go up to data, well, yours is enabled. I don't know yours probably.
Oh, it's not on there. What do? I'm stuck. Guys, I'm just going to quit. I'm done.
Go to fall.
All the work I did. Wait, you know how to do it?
Go to fall.
Just because she knows it doesn't mean you can ask her. What do? Do you know
Options.
Volzer? Let her have this win. She needs it.
I'm gonna get second.
What do you do now? File what?
Add-ins, options, add-ins.
File options, add-ins, and then what?
And then you go and click go,
Go, and what?
and you click the first little box.
Yep, analysis toolpath.
Okay.
And now what do I have over here on the right?
Yeah, but mine's not over there.
Are you under data?
Mine's over there.
That's what I thought. So how do we do it from here?
Okay, then you click that. And then you go to correlation.
There you go.
You say okay.
Uh-huh.
And then.
So you don't have it done, do you? Volzer, how do you do it? She tried to BS us, right?
Select the data and the input ranger.
Select the data. It's in columns, isn't it? We got our labels in here, and then what? Output range, yeah?
Can you select both columns at one time?
Yeah, you do.
Okay.
You put all your data in there. And when you click columns, it tells Excel that, hey, it's lined up in columns, so. And then we're gonna click OK, and what do we get? Same thing, didn't we?
Hey, why did it come up?
Here's your point, Volzer. It's the point on the end of this pen. You want it? You don't want it?
I knew I wasn't getting the real point.
This is a real point, for the record.
At this point, I really want that point accelerated. quickly towards me.
Man, I'm on it
Okay,
today.
can
You have to find out.
Okay, so,
And then click on the little up the range thing.
Yeah.
Yep, and then just click on the boxes up there that you want to do there.
Oh.
Yeah, just not right there, works. Perfect. And just click OK.
now, everybody, let's make a copy of this page. How do we do that?
Go down the bottom.
Right click. You do, and then what? And then what do you do? Smarty pants?
Insert.
Not even close. What do you do?
Copy.
Move or copy.
Just do.
Create a copy, and we'll move it to the end. It doesn't really matter, does it? Because they're the same, but. We good? Everybody good with this? Who's good with this? Who's not good with this? All right, so we have two. Now, here is challenge number 2. Build me a regression. You already did it, didn't you? Everybody else, build me a regression. How do we do that? We'll just do it on your own. You get 1 minute to do it. All right, how do we do it? Somebody walk me through it.
All right then, well, go to your data analysis pack.
Okay, so I don't have to reload this thing, do I? It's already on here, remember that. Please don't reload it every time. So let's go to data analysis and then what?
You're gonna go to regression.
Down to regression, huh? Double click that sucker. Now what's my X range, what's my Y range? What's Y mean?
Your Y is your dependent.
Y is my dependent. Which one's dependent here on the other?
Copy or sold.
Copier sold is dependent on the number of sales calls I make, isn't it? And then my X range is what?
Sales cost.
Sales calls, very good. Do I have my labels?
Yes, you do.
Yes, I do. Let's skip on down. Where do I want to output this thing?
Put range. Make sure you have plenty of space for it because it's kind of big.
All right, I2. And then,
After that, you're
actually, I want to show you these.
okay.
Just those two work. Okay, now,
You click on those two.
click OK. And what did I get?
You have a
This is the important part, isn't it? I have my summary output, my regression statistics, don't I? All right. So how do we read this sucker? What are we looking at here? What's that first one right there? Multiple R. Does everybody see that? Multiple R. What is that? What is that? Where do you see? Where have you seen 0.864?
Correlation?
Yeah, that's my correlation coefficient. Does everybody see that? That's my R. Remember? R squared. What does that do? That's my coefficient of what? Determination. Very good. Determination. And that explains how much of that, where that X variable lies is caused, or where that Y variable lies is caused by the X. That'll make a lot more sense when we get into multiple regression here in just a minute, because that way you can see that different variables cause the line to move in different ways, yeah? Different variables are more responsible for the position of that line than others, due to how they're plotted out, yeah? Okay. Standard error, what is that again? That's the what? Remember doing this? That's the spread around that line, isn't it? Remember? Oh, that's no good. That's the spread around the line, huh? So we got this thing right here, don't we? Boom, boom, we got the line up, but we got our dots in there, don't we? And that's like, sort of like the standard deviation around the line, isn't it? Yeah? The average of the distance. Okay? All right, so, remember we got a formula for that, don't we? If you don't remember, you'll remember by the time you do the homework. Let's skip the de novo analysis because we did not do analysis of variance testing, but we have those coefficients down there below, don't we? What is this first coefficient, 1998? What's our formula for that line right there? Y hat equals what? A plus what? Px, remember that? What do I know I can plug in for A right there?
Your intercept, your 1998.
Very good, 1998, isn't it? Did everybody see that? This is my A right here, isn't it? Oops, not right there, right here. Everybody see that? That's my A right there, isn't it? That's my intercept. It is at 1998, isn't it? Okay? And what can I plug in from B that you can see right there? Huh? What can I plug in for B in my formula? Point what?
That's your p value, yeah?
No, right below here?
No,
Right here.
oh, yeah.
0.26, isn't it? Everybody see that? Plus 0.26 x, right? So y hat equals 1998 plus 0.2x, isn't it? And whatever we plug in for 0.2, or for x, we multiply by 0.2 and add it to the 1998. That 0.26 is our slope, isn't it?
That's correct.
Everybody see that? So what are we talking about right here? What are we talking about with regression? Who remembers? So, we got this scatter plot from 15 people, didn't we? Remember our sample size is 15, right? We got their sales calls and number of sales they made. But what we're doing right here is we're predicting, aren't we? We say, well, what about number 16? If number 16 makes X number of calls, and we had that example of 100, remember? If they make 100 calls, X is right here, for instance, how many copiers would they be expected to sell from that 100 calls? Number 16. We know 15, and we built our model off of 15, haven't we? Now we're talking about number 16. Well, since we have this line, we can go, well, 16 would be predicted to sell this many, wouldn't it? Boom, 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 up to the line, and then over. Right? And that's our y hat, isn't it? It's not a good-looking line, but
45.98.
everybody see that? That's what we're doing here, isn't it? It's a prediction tool. Using the data we have, we're saying, what would the next one be from the same group? Yeah? And then remember, we tested the significance, didn't we? We said, well, we had these 15 from this scatter plot, but are those 15 really representative of our whole sample? Remember, we did our whole significance testing thing about that? Okay, so that's what we're doing here, isn't it, with this regression stuff, yeah? Okay, well, let me show you one more thing real quick, and why I wanted to make a copy. Because does everybody still have their scatter plot right here on the new one? All right, so I want everybody to follow me really quickly. So, everybody go to the scatter plot and put your cursor right on top of the trend line there. And right click. Okay? And drop it down to Format Trend Line. Does everybody see that? And now go down to, in the navigator on the far right, go down to Display Equation on Chart. It's 3 steps. Right click, Format Trend Line, and Display Equation on Chart. Does everybody see that? Does everybody have the equation now on the chart? So now we have what we wrote out, don't we? It's backwards, it's flipped around, isn't it? But our y-intercept is what? 1998. It's right here, isn't it? Our slope is 0.2606, right there, same as the coefficient, isn't it? Is this variable significant? Well, we can tell it's a really strong relationship, can't we? But could it just be that we just kind of pick these 15 that give us a strong relationship? Well, where are we going to tell the significance? So we didn't do this ANOVA testing, but if you look at the significance F, the F test right here, what are we talking about? What is that number if we were to write it out?
0.000003.
That's right. Does everybody see that it's 3.19 whatever, yeah? Times e to the negative what?
5.
5. Does everybody see that? So what does that mean? What do you do with that e to the negative 5?
Your decimal, put 5 zeros in.
Yeah, remember this? 1, 2, 3, 4, 5. Decimal point goes there.
Or 4, my bad.
So we have 0.0000319. Is that significant? Highly, highly. Because what? It fell way out. Remember we set our null hypothesis to 0 when we tested significance. So if it falls in the past our alpha, it becomes, we reject that null hypothesis, don't we? Where do we reject it? Where's the normal place we put our alpha? Who remembers? We want to be 95% sure, yeah?
Yeah.
So we usually do what?
0.05.
0.05. So we're talking that, aren't we? Let's say it's to 1, even if we split it up. But let's just say it's to one end over here, yeah? Is it positive? Yeah.
Yeah.
So it's to one end over here, yeah? Let's say. So this would be 0.05 alpha, wouldn't it? 0.05. This would be 95% of the area under the curve, wouldn't it? 0.95. Where is 0.0000319 compared to 0.05? It's out here on the other side of the board, isn't it? It's tiny, tiny, tiny out here, isn't it? So yeah, it's highly significant, yeah? We good? Everybody following?
So what did I miss right here?
Okay.
To the right hand side where it says format trend line.
Can you?
Format trend line.
Yeah, absolutely.
Oh, we should get her a bell so she can just ring it.
Right there where it says display equation on chart, just put that box.
Oh.
Yep. And then it shows your equation right there in the box.
Oh.
Yep.
Okay.
Chart, yep.
All right, does everybody have this then?
Yes.
So you got 2 ways of really finding your intercept and your slope, don't you? And then you're plugging in your x and you get your y.
Now, just to recap, applying the significance to, like what would our null hypothesis be, I guess, in this case?
In this case, our null hypothesis would be that that the relationship between sales calls and copiers sold is 0, equals 0.
Equals 0, okay.
You see what I mean?
Oh, yeah.
And so we're rejecting that null hypothesis, remember?
Mhm.
It actually wouldn't be that relationship in this particular case would be that the proportion of the area under the curve, the P, remember, that we saw before this time, is less than or equal to. But you could just say not equal to.
Oh,
You see what I mean? Remember, because we said or equals 0, and then our alternate would be that it's not 0. Remember?
Okay.
Do you remember? Y'all remember doing that? You remember doing that? We did it for the slope. Remember, we got a new t-test for the slope, and we have a new t-test for what? The what am I trying to say here? The coefficient, the correlation.
Oh, yeah.
We can test the correlation and we can test the slope, right? We have 2 new t-tests, remember? Please tell me you remember this. Don't worry. I made sure you're going to get plenty of practice.
Oh.
All right, so, we good? All right, now. Oh, but if you notice, the reason I was pointing out the significant stuff, where else do you see this number? Boom, look at this right here, your p-value, isn't it? Yeah, that's your p-value. Because we have one variable, okay? All right, so we can all do a regression, yeah?